Thank you very much. Good morning. I have been introduced already. We are Night Architects. We are a slightly unique studio here in the group because we only specialize in bridge design. We don't do anything else apart from bridge and infrastructures, which is an unusual field for architects to work on. I'll move on. Obviously, bridges are, as the name already say it, are engineering structures, or even in German, if you call them Ingenieurbauwerke, it brings it even more to the point. These are very efficient solutions of a problem of connecting two points. Therefore, it has always been a realm of engineers where they were showing their skills, and there's always a very long debate going on whether architects should or should not be involved in the design of bridges. There have been a lot of examples where this cooperation didn't work well, but there's also a lot of examples where engineers on their own did fantastic work. We developed a very unique way of working where we don't lead the project. We work together with the engineers who are the lead engineers, and we just advise them on how to improve their design. So we try to find a solution that is not necessarily flamboyant and iconic. Instead, we try to achieve something what we call the beautiful ordinary. So advising engineering officers on how to just slightly improve their designs to achieve outstanding beauty without necessarily increasing the costs. So why bridges? Bridges are, despite what I just said, are probably the most architectural objects of our built environment. They're all landmark objects. They're all very exposed. They are highly visible from far away. They always define a location. At the same time, they are highly poetic. They inspire artists. They inspire poets. They are a canvas for people's dreams. They symbolize peace. They connect people. They connect communities, countries, and continents. If you look at a euro note, there will be a picture of a bridge on that. So just that idea, if you think of that, immediately says it's more than just an engineering solution, a mathematical solution to a problem. At the same time, bridges are probably the most last standing objects, architectural object in the environment. Most of the bridges designed today survive their designers. They will be out there for generations, and there are beautiful designs of Roman engineers which have been here for thousands of years. So the question of legacy is a very important one. So even if you talk about an efficient bridge, you want it to have a minimum amount of aesthetics, so future generations can still tell, okay, I understand what the idea of the bridge was. Finally, what you can see here is a bridge in Stratford just before the opening of the Olympic Games in London, and this is an engineering solution, how the engineers see it. So it's beautiful, it's working, it's there, it's done. However, a couple of months later, you then see what it is all about. It's actually every single bridge, it's about the people, and it's not only the people who use them, it's also the people who live around them. So you always, when you design a bridge, you have to design the bridge always with the people in mind. I'm going to take you to London. Most of you have been there before, probably. So you can see there's the River Thames. Up there is Hyde Park, Regent's Park, and Westminster. So Hyde Park and the Paddington Station. On top of that, there's the so-called Grand Union Canal running along there, which used to be the main route of transportation before the introduction of railway. So it was basically the beginning of the Industrial Revolution. South of that, there's the so-called Paddington Arm of that canal, running down there, and this is the site we're talking about. I'm zooming in a little bit closer into that, so you can see in the north the Grand Union Canal and a little crossing called Little Venice. So not only Italians have their Venice, it's also we have one in London as well. And south of that is the Paddington Arm of the Grand Union Canal, which used to be a highly industrialized area, which is now redeveloped into retail, shopping, commercial buildings, and residential developments. So this is what it looks like. That's what Little Venice, and we don't have gondolieri, but instead of that we have a lot of those little vessels, barges, which used to be designed to transport goods. Now they're, I would call it affordable living. So people live on those boats. They dwell on that, and it's a fantastic way to live in this environment. Little Venice, what I showed on the picture, is slightly up to the north of that site that I'm showing right now. So you can see the canal is coming down from up down there and running along here, ending pretty much in this point here. This development here is called Merchant Square development. It's a dense development of, as I said before, retail and housing, including the one Merchant Square tower, which will be, with I think 110 meters, will be in future the tallest building in Westminster, called the Cucumber. The planning requirements of the Westminster Council were that if someone develops these sort of developments, it's not only about putting money into that and generating revenue. It's they have a certain of conditions they have to discharge, and one of the conditions was the improving the quality of the public realm, and this is how the whole idea with the Merchant Square Bridge emerged. On that side, before there was a bridge, it was a moving bridge which broke down due to bad maintenance and had to be replaced. So the client, European Land, said they announced a limited competition with 3 participants for a new moving bridge, which on the one hand should be beautiful and have a certain flamboyance that would attract people to the site, to use it, attract tourists, but at the same time attract attention to the new development. On the other hand, there was the planning requirements to make the bridge to move as quickly as possible. This is a diagrammatic view of the development, a diagrammatic plan view. So in the north, you see the buildings of the Merchant Square developments, including one Merchant Square, which is that Cucumber I spoke about before. To the south, that pale blue, that's the Paddington Arm of the Grand Union Canal, and the green bar is it's a peninsula called Sunset Terrace. So the entire site is enclosed by high-rises, and it's hugely shaded, except of the view to the west, which is completely open due to the direction of the canal. That means that when the sun sets in the west, this so-called Sunset Terrace is completely covered in light, and people just enjoy dwelling there. The alignment of the bridge was another thing to discuss. So when we started doing that competition that we finally won, we started to ask a number of reasonable questions. Number one is, why do you want to have the bridge on a skew? Why does the bridge have to cross there whereas the natural direction would be there. It would reduce the span. It would reduce the cost of the bridge. The impact would be less. But land requirements and land property issues didn't allow to do anything on the south bank, and also the connection on that side was blocked by an existing building that was impossible to tear down. So the natural route is going around those buildings, then crossing the Sunset Terrace, and then on a skew going onto the other side, where you join onto the Edgware Road, going further down to Hyde Park. So it becomes a very natural connection for pedestrians and cyclists. That's a close-up view of the plan. You can see in the top left a water feature, an event space, the building to the top of it, and the grassed areas of the peninsula. Now, the requirements for that bridge were that we have to cross a shipping envelope of 3 meters by 1.50 meters. That's around the size of these barges. So it's not a huge envelope. And we were wondering, so why would you need a moving bridge? Maybe there's a different way to get over that. Maybe you can just raise the bridge so far that you cross it. You can cross it without moving it. However, the penalty that we would have to pay in terms of ramps and stairs rendered that not impossible but unfeasible, and especially not beautiful. So the other approach was, let's do a moving bridge as the client required. And we started looking at, there's only a certain amount of solutions how you can move a bridge without inventing something completely new. The easiest way is to move it just vertically using 2 hydraulic jacks, only to get the bridge out of the shipping envelope. Obviously, as I said before, the land on the south side didn't belong to us, and we had no possibility to build any foundations, and definitely no hydraulic pits or anything like that. So we had to rule out that idea. And the next possible solution is a slewing bridge. So you don't need to introduce any energy to lifting it. You're just move it horizontally. However, at the end of that canal, you see those barges turning around. And the interesting part about that is no one cares about the barges. So people look at them and, yeah, it's a barge changing its direction. So it wasn't anything special. However, talking about scale, if you take this kind of barge and just put it vertically on its heel, you see the whole thing in a completely new light. You see in a new perspective. And that's to a certain extent the idea that you get in a bascule bridge, which is most of the time horizontal and very toned down, and only if a ship crosses, the bridge lifts, and suddenly the object, which remains the same in scale, just changes its direction, which changes the entire game. That's a design of us that we did a couple of years earlier in New Zealand, which is the Te Matau Apohe, rolling bascule bridge that is also won several awards. I'm just showing it to tell you to show you how the whole idea is. So you've got an object that is most of the time almost invisible, and only when it raises it becomes it shows what it does. Here's a very simple sketch of the bascule bridge. A bascule bridge consists of 2 elements. You've got the deck, which is a cantilever. On the backside, you've got a counterweight to balance it. And then you've got a set of hydraulic jacks just to push it up. It's a very common system. Probably most of you know it from excavators, JCBs, where the hydraulic arms are being lifted, used by the hydraulic jacks. So that's the way a bridge would move up, and we thought, yeah, that's a very efficient, that's a good way of moving it. Hydraulics are hugely energy efficient, they are safe, they are reliable, and they are easy to install and also to replace. which ticked all the boxes for the client who was asking for a low maintenance structure. The only thing that was missing was the flamboyant, the wow part that the client was looking for, something that would inspire tourists to come there and take pictures. So we thought, what if we just took an angle grinder and cut our bridge into 5 independent pieces, and then move each of them independently. Theoretically, the tonnage doesn't change, the amount of energy you need to lift it doesn't change, so the cost shouldn't go up much. But you would have the advantage of being able to move the bridge like this. That was finally the idea that helped us winning the competition. And that's the first scale drawing that we've shown to the client how it would work. So you see sculptural counterweights and a 17-meter long cantilever, which is a single span beam when it's down, sitting on an axle, and a set of hydraulic rams that would push the whole thing up. This is what the drawing showing the bridge in its lifted position with the highest sleeve going up to around 80 degrees and the lowest going just above of the shipping envelope. Some initial renders, and some of you will recognize there's one problem with the counterweights. They disappear in the ground and open huge gaps. I will get back to that problem later on. We did a number of additional renders, and what was very important is you can see here the bridge is very toned down. It's not, it's very quiet. It's almost too quiet. So in order to tell people that there is something interesting going on, we decided to make those counterweights quite sculptural. So although they're disconnected visually from the building, from the bridge itself, people can see there seems to be something going on. And once it's lifted, that will attract the people. We designed the whole thing in Rhino and Grasshopper together with the engineering office AKT2, who fortunately also used the same software. So it was a very enjoyable way of working where we were mainly exchanging programs and not drawings or 3D models. The geometry was hugely complex, obviously, because if you change slightly the diameter of a counterweight, the whole technical part changes, so the balance of the bridge changes and the structure needs to be redesigned. So this was the way how we used Grasshopper to optimize it. So that's a 3D model. This is what it looked like a couple of months later in the workshop. It's a company called SH Structures doing fantastic detail work. They works a lot on sculptures, have a very high level of precision. But when I arrived at the site and saw the sheer size of one beam, it was extraordinary. So all 5 beams were produced in the workshop, then shipped to London to a dockyard, and from there put on a barge and shipped down to the site. Most of you will see the fingers of the bridge were currently not in the right order. There's a reason for that, and I again can only say my compliments to SH Structures. No matter how much you think and develop a concept, at the end it's the contractor who adds the last bit of thought to make it all work. So the arrangement of the counterweights is following a curve. So when shipping the fingers down to the side, they could fit underneath the arch bridges along the canal. Let's look into the hydraulic jack pit. So we have 5 axles, 5 bearings. The fingers are sitting on each of them. Each finger is about 60 centimeters wide, so those bearings are 60 centimeters apart. They are staggered in their arrangement because the bridge is crossing the water on a skew. On the left-hand side, you can see a structure that will support the cladding that will keep people from falling into the pit, with little openings for the hydraulic jacks. Unfortunately, not big enough to get out. These are the hydraulic jacks already mounted and with the structure lifted. So each of them is of a size that it can be handled by 2 people. So if anything should break down, you can very easily replace it. At the same time, you get that very beautiful arrangement of technical elements. And I was talking about the counterweights. So the counterweights became a point of interest during the design because the client got very concerned about the pit being open when the bridge is lifted and the counterweights disappear in the ground. So what we said is we want to design the counterweights in a way to mimic the inclination of each finger. So when the bridge is completely lifted, all the counterweights remain horizontal. So they stagger, or they're staggered to some sort of a artificial staircase. And so these are the counterweights in the final mounted position, with little weights embossed on top of them. That's a slight reference to the industrial past of the site, but also it gives another hint to the people who pass it that it's actually something that has a function. And you can see here, that's a view across the bridge with the counterweights out of the ground, the bridge lowered. Once the bridge lifts, the counterweights sink into the ground, and you've got that absolutely safe space. People can walk on it. You can play on it. There's no one in a yellow jacket telling you off. It's absolutely safe. At the same time, the bridge is being exposed, and the lifted fingers reach their maximum effect. Another very important part here, which came from the side of the client, was quite late in the design process, they got worried about people in high-heeled shoes getting caught in the gaps in between. So they said, well, you've got a maximum tolerance of 3 millimeters of gaps between the fingers over a length of 25 meters. We got slightly concerned, but SH Structures managed to do it without any problems. The parapet is the other sculptural element on the bridge. And when we designed the bridge, when we won the competition, we were slightly worried that when the bridge is down, it doesn't attract enough interest because it's so toned down, it's so unobtrusive. So we came up with that concept of a stainless steel parapet with 3 centimeter thick rods interlocking without touching each other. So in three-quarter view, you've got a very opaque, very safe environment that you can illuminate from above. At the same time, looking at it from the side, it becomes a very transparent object. So that's the view from above. It's been highly accepted by people. They're using it every day. They're crossing it all the time. You've got joggers, you've got the cyclists, people from the office crossing, going to town and going to wherever they're going. And at one point, the bridge starts lifting. So that happens 3 times a week on Saturdays, Fridays, and Wednesdays, always around lunchtime. And it's a huge attraction. It attracts people from everywhere just to take pictures and enjoy it. Another very important part here is, obviously, you have a design and you do the renders, and you hope that the renders the final thing would look like the renders. But in this case, we managed to make it look even better because we managed to reduce the size of the structure. So it's a very, very lightweight object. And you can see here as well, very well, that parapet, which now is very, very transparent, looking at it in elevation. So some more comparison of the studies and what it looks like when it was finished. And it's always a great thing to see the object, the final object, look better as conceived in a concept. And I said before, it's bridges. It's always about the people, and this isn't staged. It was. I was sitting around there having a coffee, and you suddenly see children playing on that. For them, all those counterweights, they have become their own playground, and they fool around. They run up and down these counterweights, and it's just great sitting there watching it. And although we're here in Milan. London has its own fashion shows, and that's another thing that we discovered afterwards, that people started using the bridge for fashion shoots. So it wasn't something that was intended, but it's fantastic to see it being used in this way. So in total, we managed to come up with a design that's when it's in its position to be used by the public, it's very subtle. It's toned down. It's almost non-existent. It just does its jobs. It provides a shortcut. But every now and then you press the button and it reveals that architectural beauty, that sense of drama and surprise that people appreciate. And I've got a little video which will show it in motion. Thank you very much.